Hello, and today we're going to be working on PLTW Principles of Engineering, or POE, Activity 4.1.2, specifically looking at the CAD software using Onshape to complete this portion of the assignment. So first we have to download the document. So it's got the Beam Deflection Onshape document. We have to open it up and then make a copy. I'm just going to call it Beam Deflection Simulation. And then you have to tell it where to save. So I'm just going to say owned by me. You can place it in a folder. I'm going to move it to a folder later on, but I'll just copy it just to have it going already. Once we have it in here and it loads in, first you want to make sure you have this max deflection, mass beam deflection. If you did not, you have to come over here and select PLTW max beam deflection and add it in. So that gives me a second one, and that's fine. But if you didn't have it, you have to search for it, and you should be able to search for it and add that custom feature. Then first it wants us to select our beam, which is just that beam right there in front of us. Then we have to tell our two types of support. So on one side we want a fixed support, and I'm going to make that on the left side of my beam. So then we have to click on it to select what side. Then on the other side I have a free support because it's free hanging, so I want to turn over to the other side and select that edge to make that edge free. Then our load face is going to be the top. That's where the performance are going to be at. And then finally you need an input force, and they have a single point here on the end for you to input that force. From there we have to make sure we put in the correct values. So the modalus they give to us in the question. So if we scroll on down, for this assignment you're looking at question number 9, using this to basically confirm your answer to this question up above, this challenge question. So here's the stage. They already made it 6 meters long. They already made the sketch for 1.25 meter base and a 0.15 meter high beam. So as we go into our beam, then what we have to add in is the modalus of elasticity. We want to make sure that's 16 kilopascals. So as you default in, if you just add it in, it automatically goes to 16. If you edit the one there, you have to change it to 16. Then you have to calculate your moment of inertia. Remember, you do that on the end by doing base times height, and don't forget to cube it. Do your calculations. In the preview video they give you a value of about 0.0035 or something like that, I believe. Again, you want to calculate that yourself and get the actual value that goes in there. Now that we have those values, then we can see what force is needed to cause a different deflection. So in this case it defaults to 2. I'm just going to go to 10,000 just to show you. When I go to 10,000, we have a max deflection of 0.128 meters, and again that's in meters. We want a max of 1 centimeter, so do your conversions. You can already determine that's going to be much greater than 1 centimeter, and you can see that beam deflection. If we go to an even bigger value, you can really see that deflection. If I go to like 100,000, you can see that deflection there. So you want to check your value, and you should get a value of about 1 centimeter. Again, you have to do your conversion for that. I'm not going to go through. You can figure out that, determine that value. You should have a calculation value that you're double checking here. I'll get away from this maximum deflection now. I'll go back to that 10,000 we had. Once you do that and you check your answer, and hopefully you have the right answer, if not, go check your maths, get some support, and see what you need to do. Then they want you to do some edits to it to decrease the amount of material. There's a few different ways you can do that. Probably the easiest way for most people is just coming to this beam profile sketch and editing that sketch. So I'm just going to turn that to the side, and you can edit this sketch. Again, we started with a 0.125 by 0.15 meters plank, and you can edit that. You can remove pieces, you can change the orientation. It's up to you what you need to do to make it stronger in this case and lighter to be best adapted for this purpose. Hopefully this helps you as you work through this activity. If you have any questions, make sure you get that support. Thank you. Have a great day.